So now we're going to look at loans, and you'll notice the loan formula looks a lot like the saving annuity formula. It's just that the one that was subtracted in the back in the savings annuity is out in the front, and then the exponent on this part is negative as opposed to positive. And one way to think about that might help you to remember which of the two formulas to use is with the savings annuity, you're adding money to your account. So you're getting a positive amount and the exponent is positive. Whereas in a loan formula, you're losing money every month that you're paying to the loan. So you can think of it as negative exponent. And that might help you to associate the right formula. Okay, now let's notice here though that P sub 0 is the balance in our account at the beginning. It's the amount of the loan that we take. D is the payment that we make every month or every year or every semi-annually or whatever our arrangement is. Usually it's monthly, but it might be something different. R is our interest rate as a decimal. K is the number of times it's compounded per year. And then N is the number of years that the loan is for. Okay, so let's actually look at a couple of these problems. Marie can afford a $250 per month car payment. She's found a 5-year loan at 7% interest. How expensive of a car can she afford? Okay, so let's go ahead and identify everything. The $250 per month would be her payment, so that's little d. D is $250. The per month is the number of times it's being compounded, so K would be 12 times per year. It's going to be a 5-year loan, so our N is 5, and 7% interest, so R is 0.07. 7% interest as a decimal. Now let's plug in. Alright, so again, I'm going to use my draw feature just so I don't have to go to the equation editor on this one. And I'll put some extra space in here. Alright, let's go back up to the top though so we can see our formula as we put it in. We don't know P sub 0. We don't know the amount of the loan itself. So that's our unknown here, P0. But we do know D. D is 250 on the top of our fraction, out in front of these parentheses. 1 minus another set of parentheses, 1 plus R over K, 1 plus 0.07 over 12, raised to the negative NK, negative 5 times 12. Close those top parentheses. Now let's put that over. R over K, 0.07 over 12. Now, just as we did before, inner parentheses must be done first in our order of operations. So we need to take the 1 plus 0.07 divided by 12, put that into our calculator first. So if I do that, 1 plus 0.07 divided by 12, I get 1.0058333333. Now remember, just like before, we want to keep as many decimals as we can. And then let's multiply. Negative 5 times 12 is negative 60th power. And then close those parentheses. Alright, now we can do the bottom. And remember in the last one that R over K was really the same as this right here. So if you think of the 1 not being there, the R over the K is really going to give us 0.005833. All right, now, next in our order of operations, we've got to raise this to the negative 60th power. Very important, though. Whenever we've got a negative power, when we raise it to this, we need to, in our calculator, put that negative 60 in parentheses, or it could give us something that's very off as an answer. All right, so let's do the 250, or let's do the exponent part. So I'm going to put 1.0058333333 raised to the, in parentheses, negative 60 power, and I end up getting 0.7054 05038. And depending on your calculator, you might get a few more decimals than me. I'm using a little bitty calculator at the moment. If you're using a TI, you might have a few more decimal places. 3, 3, 3, 3, 3. Now let's finish the bigger set of parentheses. So let's take 1 minus this decimal, and after that we'll multiply the 250, but not yet. So if I take 1 minus this number, I'll get 0.29459 4962. Alright, just going to add some more space in here for us. Hopefully down here. We'll just ignore the B, C, D, E stuff. Okay, now let's go ahead and multiply 250 times our 0.294594962. And I get 73.6487 4052 divided by that ugly denominator. And then finally, let's divide those out, and we will have our answer. Okay, so she can afford to buy a $12,625.50 car. Not that the cents are going to make a whole lot of difference. Alright, so she can only get a $12,000 to $13,000 car with a $250 per month car payment. And let's face it, that's probably the case. If we really think about it, $250 car payment is not very high. It's probably a used car that we're talking about here. Alright, so let's now go to the second part, which should be part B, but of course it changed when I was hitting the return button. How much total money will she pay for the loan? Well, let's remember she's paying $250 a month, and she's doing it for 5 years, and and of course every month. So let's take $250 a month every month for 5 years, so 12 times a year for 5 years. Let's see how much money she actually ends up paying. So 250 times 12 times 5 ends up being $15,000. that she actually pays. So the car she's buying is $12,625, but she's going to pay $15,000. And we know that, of course, when we're paying for a car, we're going to pay more than the car is worth because we're paying for interest. All right, so how much of that money is interest? Well, let's just subtract the $15,000 minus the worth of the car, or the amount that gets financed, and we will have how much interest there is. So $15,000 minus $12,625.50 ends up being, we pay $23.74.50 in interest. And I'm going to save the second problem for a different video so we won't run out of time.